Ever wonder how we can send rockets to Mars, build skyscrapers that touch the clouds, or even just predict where a thrown ball will land? It might sound like modern magic, but a huge chunk of the science behind it all comes from the mind of one man who lived over 300 years ago, Sir Isaac Newton. His story isn't just about a guy getting hit on the head by an apple. It's a tale of relentless curiosity, revolutionary ideas, and a pandemic that, believe it or not, helped change the world forever. So, let's rewind the clock to the mid-1600s in England. Newton was a student at Cambridge University, a brilliant but notoriously difficult person. He wasn't the life of the party. He was the quiet guy in the corner, completely absorbed in his books and experiments. Then, in 1665, disaster struck. The Great Plague swept through London and other cities. Cambridge University shut down, sending everyone home to wait out the deadly outbreak. For most, it was a time of fear and uncertainty. For 20-something Isaac Newton, this lockdown became his year of wonders. Forced into isolation at his family home in Worcester, Newton's mind didn't shut down, it went into overdrive. With no professors to guide him and no lectures to attend, he was free to explore whatever fascinated him. And what fascinated him was, well, everything. He tinkered with light and prisms, laying the groundwork for his groundbreaking work in optics. He developed a new form of mathematics, which we now call calculus, just because the existing math wasn't good enough to describe the things he was studying, like how things change and move over time. And, of course, there was the apple. Now, the story of an apple literally bonking him on the head is probably an exaggeration, but the core idea is true. He saw an apple fall from a tree in his garden, and while anyone else would have just thought, snack time, Newton asked a question that would change everything. Why did the apple fall straight down? Why not sideways, or even upwards? He realized some invisible force must be pulling it toward the center of the earth. But here's where his genius truly shines. He didn't stop there. He looked up at the sky and saw the moon. He wondered, is the force that pulls the apple to the ground the very same force that keeps the moon in orbit around the earth? At the time, this was a wild idea. People believed the heavens and the earth operated under completely different sets of rules. The celestial bodies were perfect and divine, while earthly objects were flawed and subject to decay. Newton dared to suggest that the same laws applied everywhere. The universe, he proposed, was governed by a single, universal set of rules. This period of intense, isolated thought laid the foundation for his masterpiece. Years later, in 1687, urged on by his friend, the astronomer Edmund Halley, the Guy Halley's Comet is named after Newton, finally published his work. It was a book called Philosophiae Naturalis Principia Mathematica, or Principia for short. This book is arguably one of the most important scientific texts ever written. It wasn't just a collection of ideas. It was a complete mathematical system for describing the motion of objects, from falling apples to orbiting planets. And at its heart were his 3 laws of motion and the law of universal gravitation. Let's break them down, because they're not as complicated as they sound, and they're literally everywhere in your life. Newton's first law of motion is the law of inertia. It says an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction, unless acted upon by an outside force. Think about it. If you slide a book across a table, it eventually stops. Why? Because of friction, an outside force. But if you were in the vacuum of space and you pushed that same book, it would just keep going and going and going forever until it hit something. This law tells us that things don't just change their motion for no reason. You need a push or a pull. Next up, the second law. This is the one you might remember from school. Force equals mass times acceleration, or FMA. This is the powerhouse of the 3 laws. It tells us exactly how an object's motion changes when a force is applied. If you push something, it will accelerate, meaning its velocity will change. The more massive the object is, the more force you need to apply to get it to accelerate at the same rate. It's why it's much easier to push a shopping cart than a car. It also explains why a harder kick makes a soccer ball fly faster. This simple equation is the key to calculating everything from how much thrust a rocket needs to escape, Earth's gravity to how a car's engine needs to perform. Then we have the third law of motion. For every action, there is an equal and opposite reaction. This one is my favorite because it's so elegant. When you push on a wall, the wall is pushing back on you with the exact same force. You don't see the wall move because it's massive and firmly attached to the ground. But think about a rocket. It shoots hot gas downwards. That's the action. The equal and opposite reaction is the gas pushing the rocket upwards, launching it into space. When you swim, you push the water backward, and the water pushes you forward. Every time you walk, your feet push on the ground, and the ground pushes you forward. It's a constant, invisible dance of forces. These three laws together provide a complete framework for understanding motion. But Newton wasn't done. He had to explain the why, the force behind it all. That brings us back to the apple and the moon. His law of universal gravitation. This law states that every particle of matter in the universe attracts every other particle, with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Whoa, that's a mouthful. Let's simplify. It means two things. First, things with more mass have a stronger gravitational pull. The Earth has a much stronger pull than you do, which is why things fall towards it. Second, the force of gravity gets weaker with distance, and it gets weaker really fast. If you double the distance between two objects, the gravitational force between them becomes 4 times weaker. This was the beautiful, unifying theory he was searching for. The force that made the apple fall was the exact same force that held the moon in its orbit around the Earth, and the Earth in its orbit around the sun. It wasn't two different sets of rules, it was one. The moon is constantly falling toward the Earth, but because it also has a sideways motion, it constantly misses, resulting in a stable orbit. With this one law, Newton could explain the tides, the paths of comets, and the motions of all the planets. He gave humanity a predictable, mechanical, and understandable universe. The impact was immediate and profound. Newton's work dismantled 2,000 years of old thinking and launched the Age of Enlightenment. It showed that the universe wasn't a chaotic, mysterious place run by whims, but a grand, orderly machine governed by mathematical laws that humans could discover and understand. This new confidence in reason and observation fueled advances in engineering, technology, and every field of science. The Industrial Revolution, the machines that powered it, the bridges we built, the way we understood our solar system, all of it stands on the shoulders of Newton's Principia. Of course, science has moved on since Newton. In the 20th century, Albert Einstein's theories of relativity showed that Newton's laws weren't the complete picture. At very high speeds, close to the speed of light, or in very strong gravitational fields, like near a black hole, Newton's laws start to break down. But here's the crucial part. For almost everything we experience in our daily lives, from playing sports to driving cars to building bridges, Newton's laws are still incredibly accurate. They are the foundation upon which modern physics was built. Einstein didn't prove Newton wrong. He stood on Newton's shoulders to see a little bit further. So, the next time you see a building crane lifting a steel beam, or watch a satellite streak across the night sky, or even just toss a piece of paper into a trash can, take a moment. You are witnessing the elegant, powerful, and universal laws discovered by Isaac Newton, a man whose incredible curiosity, unleashed by a period of forced isolation, gave us the tools to understand the mechanics of the entire cosmos. His legacy is a reminder that sometimes the biggest breakthroughs can come from asking simple questions about the world around us. Thanks so much for watching. If you enjoyed this journey into the mind of a genius, Don't forget to hit that like button and subscribe for more stories from the history of science. See you in the next one.